winemakers are quite interested nowadays in the possibility of choosing specific levels of oxygen ingress, which is something that certain closure types, in particular, certain closure manufacturers of microagglomerated and synthetic co-extruded, offer to a very large extent. If you go in their catalogs, you find a lot of different figures about specific product with specific, well-measured and very well reproducible oxygen ingress levels. This is not necessarily a characteristic that we associate a lot with natural cork. That can be a lot more variable in this, but also, of course, there is still a strong perception for natural cork being associated with high-end, more prestige type of wine selections. Okay. This is part of the fact that natural cork is a natural product, so it has its heterogeneity, is also very unique, and for many consumers, still very appealing type of packaging choice. Okay. So altogether, what this is telling us is that there is a lot of situations in which we might not be able to control the amount of oxygen that goes inside our bottle, and this can cause various and random levels of oxidation inside the bottle. The good news is that there are technological solutions today to control all these situations and make our bottling more consistent and reproducible, and also the oxygen ingress in the bottle more consistent and reproducible. Okay, so that's a very important concept for winemaker, is also the consistency, you know, that every bottle ages in the same way. Okay. And depending on where you find the problem, then the solution is different. You might need to fix certain aspects of bottling, fix certain aspects of closures, selection, or fix both. Okay. So this is the chemistry that is behind what we just discussed. I remind you once again, is what we call the oxidation cascade. Okay. It can go far if we're not very good at making wines that are rich in what we call protective compounds. Now, from a chemical point of view, very much we talk, you know, mostly researchers talk about nucleophilic capacity. So the nucleophilic capacity of a wine is its ability to neutralize the impact of the electrophiles that circulates around the wine, especially when there's oxygen. And these are, as we said, quinones and hydrogen peroxide. So that's a very important characteristic. And SO2, for example, is a very effective nucleophilic compound. Glutathione also is quite effective. Okay, so these are compounds, species that are interested for us, especially SO2, because among them, SO2 is the only one that has the capacity to also react very quickly with hydrogen peroxide, and also provides the antimicrobial capacity. Okay. Remember also that SO2 binds to acetaldehyde. This binding is reversible. So as we consume free SO2, we will release the aldehydes that are trapped in the complexes with SO2. So the bound SO2 is a reservoir of aroma compounds that can bring into our wine oxidative characters. Okay, so really be careful also with high levels of bound SO2, because that's a reservoir of potentially negative aroma compounds. So really be careful about